For example 3, again, we're going to simplify the rational expressions. So here's a very simple one, x plus 2 over 2 plus x. So the question is, are they the same, and will they divide out as common factors? And the answer is yes, they are, because of the commutative property. 2 plus x is the same exactly as x plus 2. So these two things are equal. So we see here that then these are common factors, and they're going to cancel to make a 1. So that answer is just going to be 1. However, on B, I have 5 minus x and x minus 5. So are those the same? I'm going to reverse the order, and when I do, I get a negative x plus 5 in the numerator and x minus 5 in the denominator. You can see they are not the same. But what I can do is I could factor out a negative 1 from the numerator. And when I do factor out that negative 1, so negative 1, it's going to change the sign. So it's going to make the x positive and the 5 negative. So then I have the x minus 5 in the denominator. So by factoring out the negative 1, I come up with these common factors of x minus 5 and x minus 5 here. And so these will create a 1, and what I'm left with then is negative 1. So 5 minus x over x minus 5 reduces to negative 1. So helpful hint, we don't want to always go through all those steps. Helpful hint, when the numerator and the denominator of a rational expression are opposites, for example, x minus 3 and 3 minus x are opposites of each other, the expression simplifies to negative 1. All right, so let's use this in this next problem. So I'm going to need to factor the numerator. It looks like they have a GCF of 2. So I'm going to take out a 2. That's going to leave me with 9 minus x to the second power. And we've learned that factors again, that's the difference of squares. So this is going to be 2, and then this is going to factor into 3 minus x, 3 plus x. Then the denominator, we're going to use the AC method on it, and I'll write it over here. It's going to factor into 2 parentheses. I want two numbers that multiply to be negative 3, so that's going to be a 3 and a 1, and with the 3 negative and the 1 positive. So x minus 3 and x plus 1. All right, so now I see the x minus 3 and the 3 minus x, which are opposites, and I know that these are going to cancel to be negative 1. So I have a negative 1 there, a 2 here, and then I have the 3 plus x over x plus 1. So I'm going to end up with, I'll put the 3 plus x here and the x plus 1 there. So this is going to reduce to be negative 2. And I'm going to put the x plus 3 this way. So I'm going to reverse that order. And then over x plus 1. I like to have the x in front. And that's going to be my answer. Now, as I write this, you're going to think, where do I put the negative? I have this negative 1. Where do I put it? Do I put it here where I put it, or down there? Where do I put it? And here's the helpful hint. In a rational expression, a negative sign can be placed in any of these 3 places. So as I did it, you could place it in the numerator, and or I could place that negative instead in the same problem in the denominator, or I can place it out front, just in the middle, in the front of it, just in general. It does not matter where it's placed. To multiply rational expressions, step 1, again, completely factor each numerator and denominator. Step 2, multiply the numerators together and then multiply the denominators together. And then step 3, simplify the product by dividing the numerator and denominator by their common factors. So look for the common factors, just as we did when we simplified fractions. All right, so here you can see I've already done my AC method. I'm going to factor. This doesn't factor. This doesn't factor. So I've got 1 plus 3n, and I'm going to multiply. This is going to factor to 2 times n minus 2. So I'm going to have 1 plus 3n times 2. I'll put my parentheses, and then n minus 2. And in the denominator, I'm going to have the 2n. And I'm going to multiply it times 3n squared minus 2n minus 1 factored, which I've got written over here as n minus 1, and 3n plus 1. I'm going to look for common factors, and you can see I didn't really write them above each other, but you see the 2 here. So those are going to make a 1. And then the 1 plus 3n, and the 3n plus 1, remember the order in the addition doesn't make any difference. So these then are the same, because I could have worked on putting those above each other. And those are also going to form a 1. And so then what I have left over here is and the numerator is going to be n minus 2, because both of these canceled. I'm left with an n, don't lose that n, and then an n minus 1. And typically when you're doing these big fractions like this, you can leave your answer in factored form. You don't need to distribute that out. So we can leave the n and the n minus 1 separate like there. Then B, we have, look there at x cubed minus 1, which we're going to factor into x minus 1, it's a difference of cubes, x squared, opposite sign, plus x plus 1. And we're going to multiply it times 15x squared. So we're going to have times 15x squared. And then in the denominator, I'm going to factor a negative 3 out of this. So negative 3 times x plus 1. And then try the AC method, but it won't work. X squared plus x plus 1. There are not two numbers that multiply to be 1 and add to be 1. So now I'm going to look for common factors, and you see here this big one. These big ones are exactly the same, so these are going to divide out to be negative 1. Then these are different. X minus 1, x plus 1 are different. Then I've got the 3 and the 5. So actually 15 is 3 times 5. So the 3's are going to are a common factor, so they're going to cancel out. And I'm going to be left with a 5 there. So it looks like what I've got, I'm going to put the negative in the middle. I have this x squared. I have the x minus 1. And in the denominator, see, 3's canceled. I have the x plus 1. And that's the answer.